inductor, one capacitor, one resistor, all in the same circuit. I apply some voltage here, A sine omega t, and I measure V out over here. This is 2 ohms, that's 0.1 farads, and this is 3 henries. The question here is determine omega so that V out is maximum. Okay, so this question involves this analysis we're doing. It's got sinusoidal voltages and stuff like that. And I want to find out what value of omega is needed to make that voltage as big as possible. Different values of omega are going to give different impedances here, which will give different values of V out. Okay. Let me give a hint, and then we'll see if we can do the rest of it together. Suppose I have a good old easy DC circuit. That's 10 volts. This is 2 ohms. And that's question mark. What value should the question mark be to make V out as large as possible?
0.
You guys agree with Roger?
Infinitely close to 0. But not
Let's make it 0.
If we could, I think Roger, if I'm not allowed to do 0, I'll get infinitely close to it. Roger's saying let's go all the way to 0. Basically, Ryan agreed. Fred, do you agree?
Yeah, 0.
And how do we know? By voltage division, we could do that divided by that plus that gives V out. So the best we'll do is to make that 0. Okay, so if I would like to make V out as big as possible, what do I want to do to that? What do I want to do with that impedance?
0.
Make it 0 if I can, or at least make it as small as possible. What is the impedance in terms of omega? What's the impedance of this 3 Henry inductor?
3I omega.
What's the impedance of a 0.1 farad capacitor?
1 over 0.1 I omega.
So that's negative 10I.
Yeah. Is it right? Oh, okay.
No, it wouldn't.
Almost.
No, yeah, it's omega.
So 1 divided by 0.1 is 10. 1 divided by I, you can multiply top and bottom by I, and you get I over I squared, which is I over negative 1, which is negative I. But then the omega is still stuck in the bottom. Okay, so I'm going to replace the inductor with 3I omega, and I'm going to replace the capacitor with negative 10I over omega. So, do you think it's possible I could get these two to cancel each other out when I add them together?
Yes. You can get close, maybe.
Okay, well, if that were a plus, I'd say no, probably not, right? Because I can't add two positive numbers together and get 0. But because one of them is a minus, there seems to be maybe hope that I could get them to cancel out or at least be close. So to make V out a maximum, I want these two to cancel each other out. So I'd like 3I omega plus negative 10I over omega to equal what, if I can?
0.
0, and I'll solve it for omega.